Assalamualaikum warahmatullahi wabarakatuh. For hydrographic survey type 3 is tide gauging. The purpose of tide gauging are to measure the change in sea level relative to a datum and tsunami warning system. To be specific, tide gauge are used to measure tides and quantify the size of tsunamis. The measurements make it possible to derive the mean sea level, and a tsunami can be detected when the sea level begins to rise. So, this is an example of tide gauging instrument. The way it works is when water enters the device by the bottom pipe, an electronic sensor will measure its height, then the data will be sent to a tiny computer. This involves the location of tide gauge at intervals over the area to be surveyed, and the number employed depends on the accuracy required. Next, the difference in tide level or tidal gradient can be determined by initially setting up gauge at each end of the survey area and comparing simultaneous readings over a complete tidal cycle. The gauge themselves must allow the following measurements to be made simultaneously. First, the levels of the undisturbed sea, and the second one is the time at which this level occurs. There are two types of tide gauge, namely non-recording and recording type. They may be either visually recording or self-recording. The simplest types of tide gauge is staff gauge, which is a vertical staff with 150 mm broad and painted graduations covering sufficient length to deal with the highest and lowest noon tide. So for the second picture is an example of staff gauge.
Next, type 4, which is the marine survey. The procedure is first mark the lowest and the highest tide. This is the example that we need to mark the lowest and the highest tide. Next, carry an open survey along the shoreline using compass or light. The picture is example that we are using light that carry the open survey along the shoreline. Then, obtain the configuration of shoreline such as reduced level, distance, and bearing. This is how we obtain the distance and also the bearing from the shoreline. Then, determine the depth of water around the harbor using echo sounder, such as the observation like rock, large rock, sandbar are located. This is the example of sandbar, and this is how the echo sounder determine the depth of water around the harbor area. Then, procedure 5. Identify the current and tidal characteristic. Take necessary precaution for safe movement of ship. The difference between tide and current. Tide goes up and down while currents move to the left and right. Tide creates the current in the oceans. Tides are characterized by water moving up and down. The term of currents describes the motion of water. The tidal current is the periodic movement of water driven forcibly, and there are 4 types of tide, which is high tide, low tide, spring tide, and neap tide. Then, position suitable lighthouse location indicating a surface road for ship and boat. Locate the position of large rock, submerged hill, and also sandbar. Then, the profile of seabed is prepared for navigational guidance, and soundings are taken at regular interval and recorded. This is an example of this profile of seabed. Then maps are prepared to indicate observations such as the position of submerged hill and also the sandbar. Fundamental task is divided into 3 elements, which are vertical control, horizontal control, and determination of bed profile. Vertical control, we can determine the position of vertical control by using the vertical elevation. The chain of benchmark must be established near the shoreline, and this serves for setting jacket tight gauge to which the sounding are referred. This is an example of the benchmark that we are using. Then tight gauge are used to establish the common datum before sounding is taken. The horizontal control may consist either a triangulation or a traverse. The underwater and near water point may be located with reference to triangulation or traverse. Triangulation may have to be employed for horizontal connection of widely separate points. Traverse done by chain, tape, or threaded light depending on the station. Okay, this is the triangulation or traverse that we use for horizontal control. Then determination of bed profile can be determined by traditional or modern method of survey. At this stage, double working for suitably established control station. This is the example of bed profile. Then principle of water depth measurement. It consists of 2 methods, which is direct method and indirect method. Direct method consists of sounding rod and sounding line, while indirect method using echo sounding. Sounding rod is suitable for measuring depth 2 meters from water surface at low velocity of flow. It is made of wooden, bamboo, or a steel pole. The diameter is 5 cm and length is 2.5 meter. Then it's provided with disc of 15 to 20 cm diameter at the bottom and scaled every 10 cm. The method is the rod is immersed until this touch the riverbed and reading note at a scale. This is the example. This is the sounding rod that attached at the survey vessel. Then it will immerse in the water until it reaches the riverbed. Then the sounding line. It is suitable for measuring depth 2 to 10 meters from water surface at medium to high velocity of flow. It is made of a long steel rope or cable attached with 5 kg weight. The diameter is same, which is 5 cm, and length is 2.5 meter. It is provided with pulley system attached to the board. And method, cable or rope is immersed until weight touch the riverbed and mark is made on the rope. Measure the length using the tape. Okay, this is the line and attached with the weight, which is 5 kg. When the sounding line is immersed in the water and reach the riverbed, the mark is used to identify the length and measure using the tape. Then the equipment. The boat is used for taking depth reading in the open sea. Sounding pole and rod measure the depth of water, and lead line and sounding line is measure the depth of water. Indirect method, echo sounding, shape with echo sounding conducted with aid of aircraft and sophisticated electronic sensor system. This is the example of echo sounding. It is suitable for measuring depth more than 10 meter and sea, made of electrical instrument to produce sound. The equipment is placed at the water surface. This is the example that the ship with echo sounding is placed at the surface of water. The concept of echo sounding, the sound wave are reflected from seabed and received by echo sounder. The system will record the travel time and calculate the water depth based on the velocity principle. So the formula is velocity equal to distance over time.
Assalamualaikum. For the end of this subtopic, I will talk about error in hydrography. Okay, For the source of error in hydrographic survey is instrumental error or peripheral equipment. So, in this, instrumental error is happen when the instrument being used are inaccurate. The second one is error in reading instrument. Instrument error refer to error of a measuring instrument or the differences between the actual value and the value indicated by the instrument. There can be error of various type and the overall error is the sum of the individual error. Next is the control not established, checked and adjusted before beginning to collect details. And the fourth one is control point too far apart and poorly selected for proper coverage of an area. Okay, we can see that the picture under the instrumental error box is the picture of the instrument that used to do the hydrographic survey. This shows that to use the instrument must reduce the error to get the best data. For the fifth of source of error is site taken on data point that are too far away, and the last one is poor selection of points for contour map. Okay, next we'll be moving on in mistake in hydro survey. The first one is unsatisfactory equipment, which means the equipment is not updated or have been damaged. Mistake in instrument reading, which means we don't know how to read the reading and make a mistake. Too few or too many data taken will also provide mistake in hydro survey because it can cause too much error. And the last one is failure to collect mapping details, which lead to a very massive error in hydrographic survey.